Welcome everyone for today's NPTEL course, Environmental Chemistry, and this is the eighth week live session. I am Saptarshi Bose here, a PMRF research scholar from IIT Madras. So today we'll try to solve few numerical questions as well as few conceptual theoretical questions. So the first question is theoretical conceptual question. You can see the consider statements below and choose the statement that are true. So you have to choose the correct options. That is the game here. So the first one is complexation generally increases the total concentration of metal ions in the solution. Then the extent to which calcium ion can be removed by this lime soda softening to form calcium carbonate in the form of solid or precipitate may be limited in parts by soluble complexes of calcium ions. Then the next option, complexation decreases the toxicity of metal ions whose predominant toxic species is the free metal ion. So, and the option D, you can see that in the COD test, mercury salt is added, otherwise the COD obtained will be underestimated. The last one is about the EDTA. Quickly check this and try to answer through your chat section. Okay, so the first answer from Laganathan, that is option B and C. Okay, we'll check. Yes, the B and C and also A. So I'll give the reasons. Please try to note it down. So the first one is already written. You can see this complexation will lead to the reduction in chance of precipitation. So it will convert the ions into dissolved form. So it will come into the solution basically. So it will prevent the metal ion from going out of the system as a precipitate. So this is the basic fundamental understanding behind this, right? So it will reduce or prevent the metal ions from going out from the system. And then the option B, the extent to which calcium uh, ions will be removed. What is the like by the lime and softening? So what is the explanation or the reason behind it that due to the soluble complexes, what is this ions are forming will be less, right, in the system. So this is my equation. CaCO3 is can be coming from this is a solid precipitate form. Solid precipitate form. It is coming from Ca2 plus ion and carbonate ions, right? And if I write the K value, then it will be multiplied. And this is the solid, that's why it's 1, right? We will not write CaCO3 here. So I hope you all know the reason behind it. And you have gone through the theoretical lectures. So why I am not considering CaCO3 at the bottom. So okay, it's okay. So when this Ca2 plus ions are dropping down, the concentration is getting reduced, then this K value will also reduce, right? This is the multiplication of these two. So when this is going down, this K value will be down. So the coefficient or the reaction coefficient will be less. Okay. Hence the extent of precipitation of CaCO3 will be reduced. So if this K value or this the reaction coefficient goes down, then this conversion will be slow, or the extent of the precipitation will be low as compared to uh, the system which don't have this the Lanzhou effect. Right? So then we are going for the next one. The complexation decreases the toxicity of the metal ions whose P dominant toxic species is a P metal ion. Right? So yes, that due to the formation of complexes, the free metal ion will be less. This is a basic understanding, nothing else. So now the number D, why it's wrong? Because see, in the case of the COD test, what happens? We use this mercury. It is written as the mercury salt is added. Otherwise, the COD octane will be underestimated. So this is wrong. It will be overestimated. Why? Because in case of COD test, what we are doing is we add this. We need to basically get uh, away or get safe from these chlorine ions, right? This chlorine ions, what it will do, it will take up the oxidizer. Like you are using K2CR2O7, or you can use this H2SO4 concentrated sulfuric acid. But what will happen? This Cl minus ion will take up. So it will be a misinterpretation of your COD. So you will not get the exact COD value that is present there. So this will interfere. This will create Cl minus ions. So chlorine ions will create some interference. It will take up the oxidizing agent and you will get a different value. So that's why we are using this mercury. So it will first take up this chlorine ion, available chlorine ion in the solution, then we can get the exact COD value, right? So this statement was wrong. It will be not underestimated, it will be overestimated because chlorine ion is also taking up some oxidizing agent. So you will add more K2Cr2O7 than the required amount, right? You will add more concentration of H2SO4, right? So that is the problem. And then duration, during hardness test, we add EDTA which allows magnesium ions to be free so as to keep the true endpoint of titration. Actually, what happens that so first the EBTA, right? We add EBTA first, and this EBTA will form the complex with magnesium ions, right? Then the complex is titrated with EDTA. Why? Because this EDTA will replace this EBTA. Like there was initially EBTA-Mg complex, now we are getting EDTA-Mg Mg2 plus complex. So that is the reason, right? Then we will move to the next question. This is a numerical question. Try to solve using Riemann-Tat to determine the dominant species of cadmium in the seawater. So you can get the data with the total cadmium 2, that is Cd2 plus is 4 microgram per liter, and that ionic strength is 0.7 molar. Consider OH minus ion, Cl minus ion, HCO3, carbonate ion, and SO4 2 minus as possible complexing agents, ligands. So use the concentrations of these ligands given in the table below. So you can check the data from here, how much sulfate ions are there, how much chlorine ions are there, like 2710, then 19,400, and like that. So you have to find out which is the dominant cadmium species, resolved cadmium species. The options are given A, B, C, and D. We will go for the solution. So the correct answer will be CdCl2 in the dissolved or aqueous form, right? So how I will try to solve using Vmintech? It's very easy to use the Vmintech. So you know what is the data here. Total cadmium concentration 4 microgram per liter. Then the ionic strength is given 0.7 molar, and we have to consider these species, right? OH minus, Cl minus, and bicarbonate, carbonate, sulfate. And other data are also given in this table format. So take care of this data. We will use those. So cadmium 2 plus concentration 4 into 10 to the power minus 3 mg per liter. Then pH is 7.9. It was also given there. Then chlorine concentration is 1900 400 mg per liter. Then we are getting ionic strength from the question itself 0.7 molar. We know what is the sulfate ion concentration, and we also know the alkalinity in the form of 120 mg per liter CaCO3. So go to the vMintex software. You will find at the top there is a specify. There is some menu. You will find this specify alkalinity right from here from the top. So go there, specify this alkalinity 120 mg per liter. Go to vMintech at the top of this place. You will find this alkalinity specification, specify alkalinity option. So go there, just type this much amount 120 mg per liter. As CaCO3, there will be some units CaCO3 or something else mg per liter or carbonate, bicarbonate. All those options are given. You have to choose the correct one, which with respect to our question, right? Then go and add these things, right? You know how to add these things: cadmium concentration, Cl concentration, add ionic strength also, and also specify the pH. You all know how to specify pH, but where is that option? So you will get, and then if you go to the view or edit list, you will get this table. So see the chlorine concentration 900, 1900, 400, 19,400, sorry. Cadmium is 0.004. Then sulfate ion is how much? It is 2,710. Everything is given. And if you specify this alkalinity as a form of CaCO3, you will get these carbonate ions in the form of carbonate ions here, like 143.8849. So you don't have to give this input. It will take by itself. You just give the input of alkalinity, you no need to give any input for carbonate ions. So it will take up itself. You will see it is there. Also, don't forget to specify this ion strength and pH, right? Then we will go to the next step. So run the vMintech. You know how to run the vMintech, and then you will get this uh, species distribution table. So if this is the main table, so at the bottom you will get this species percentage distribution or species distribution table. So from that you can find out what is the percentage total concentration, right? So here we will try to find out which is the more dominating, which has the more uh, concentration, right? So this is my range. This is the cadmium ion range within which I will try to search, not here and there. So that's my question. So this is the most effective, most highest concentration, right? 49.448. So this is corresponding to CdCl2 aqueous solution. So that's why my answer is CdCl2 with the concentration or the percentage of 49.45%, right? The next question, oh yeah, for this also, please try to use Vmintex software for every question whatever we are doing. So the owner of an industry that generates a wastewater containing both Ag plus and Hg plus. Ag2 plus is considering two options for discharge of the water after treatment. So one option is just discharge this into the ocean, right? This ocean. With in that case, the initial dilution is predicted as the concentration of 0.04 mg per liter total Hg and the 2.5 mg per liter total Ag. So it will be the concentration after dilution in the ocean water, right? And the another alternative option is to discharge in the river, in a large river. So in that case, the dilution would be very faster and more extensive due to these turbulent forces. And in that case, we can see the concentration for both Ag plus ion and Ag plus ions. These things, the concentration of Ag plus and Ag plus ions will be lower by a factor of 10. So it is getting reduced with respect to the concentrations are getting reduced with respect to the ocean. So that is the main factor here you have to take care of. So in case of ocean, the concentrations are higher. In case of river, the concentrations are lower by a factor of 10. And then one statement is given, that is Ag plus and Ag2 plus ions are toxic as a free ions than their complexes. So it's much more toxic in the form of free ions with respect to the complexes. Now the major complex ingredients in the two potential receiving water are chlorine. So the concentrations are given with respect to ocean, how much, 19,400, and with respect to river. And same for the sulfate ions, what is the concentration for ocean and what is the concentration for river. Now both the solutions are at pH 8. So that means that in case of ocean water and in case of the river water, everywhere the pH is 8. Consider this. And ionic strength of is 0.62 molar. In case of ocean and in case of water, that is 0.01 molar. Now the what will be the suitable option according to you to reduce the toxicity? So that is the question. You have to choose the correct answer. Use Vim Intex software to calculate this. We will go for the solution. So the correct answer will be ocean outfall. Uh, we have few data like what is the total concentration of Ag, what is the total concentration of Hg in case of ocean outfall. So take the data from the question. It is 2.5 mg per liter. Then Hg concentration was 0.04 mg per liter. Then sulfate concentration this much, and chlorine concentration 19,400 mg per liter. pH we know 8 and ion strength 6.62 molar. Now you have to give all the inputs in the V-matrix software. So whatever the data are written here, please try to give the inputs, right? Please try to give the inputs, and then you will get this table. So please don't forget to fix the pH at 8 and give this ionic strength, mention the ionic strength at the font in the main interface of Vmatrix software. The main interface of Vmatrix software input interface, you will get this ionic strength mentioned. Yeah. So if you do that and go for the view and edit list, you will find this list. So this is Ag1 plus concentration 2.5, this 0.04, this 19,400, 2,710. So everything is okay. Then if you run this Vmatrix software, you will find the concentrations, right? And from here, if you just look what is the concentration, you will find the P concentration, P ion concentration for Ag1 plus and Ag2 plus is comparatively less, or you can say the negligible, and with compared to their complexes. These, if you saw not this, sorry, if you just go through this much of data or this much of information, you will find that with respect to this and this, these two values are much less. This is 10 to the power minus 21, and this is also very less. Then if we go to this one, the percentage distribution at the bottom, if this will be the main table, and at the bottom you will find this percentage distribution and or the few species distribution table. If you go there, I will get with respect to total concentration with the percent of the total concentration. Here also you can see that Ag1 plus, that is the main forms, are very less with respect to the complexes, right? So the percentage of the total concentration of free ions Ag1 plus or Ag2 plus is very less, very very less. So if you see that they are forming mostly complexes, right? They are mostly forming complexes here and here. You will hardly find Ag1 plus and Ag2 plus here. So you can from this table also you can say the concentration, the percentage so low that there is no mention of it, and we can go for this ocean outfall option. But we have to check for river also whether it's much better or not that much better, that much good. How is it? We have to know, right? So we cannot decide by just saying this table. So let's calculate for the river also. So for river, this will be the data. It's 10 times lower than the C concentration. So that's why I am getting 0.25. Earlier it was 2.5, right? So 10 times lower, 0.25, and Hg is also 10 times lower. This data are given, everything are given there. So you just need to give the inputs on the main interface and you will get this table, right? This is nothing but whatever is written here, simply written in the form of table of Vminted, right? Same as the previous one, run this, and here you can see there are some portion of this Hg plus 1 plus and Ag1 plus and Ag2 plus ions, right? So, and also if you just compare between these two, Hg1 plus and Hg2 plus, you will find that Hg2 plus concentration is negligible. It's 10 to the power minus 18, but the Ag1 plus ion is considerable, 10 to the power minus 7, right? And if we go for this percentage table, you will find that, yeah, you can find C. Here, we can see Ag1 plus, right? So we can see that concentrate the percentage is 36.036%. So approximately 36% of Ag1 plus ions we are getting. So this is very high. So it will cause the toxicity. So the river is not a good option, right? Only the ocean will be the good option. So this is the next question. Quickly go through it. The solution is prepared by adding aluminum fluoride. Concentration is given 0.1 molar distilled water, and if H plus F minus and AlOH3 are the selected components, then which equations are the correct? Or which equations are the correct? Okay, we'll go for the solution because we don't have much time. So these these are two correct options, right? So I'll tell you how to solve this. So the components are given, and you can write down the species. This will be the species H plus OH minus L3 plus, and then these are the ligands with the complex ligands. So you can write it down, and then also you are getting HF, right? So the formation equation, if I write that from 1H plus, I'm getting 1H plus, and this equation you know all know. So if you just subtract this H plus from H2, I will get OH minus, right? So this is the relation between these, like actually H plus and OH minus is forming H2. This is a simple thing. H plus and OH minus is forming H2. If you just take H plus here and there and rewrite it, and also you should know the concept behind this, not just it's a mathematical expression, but you should know the concept behind this, then you can write it. So these are the very easy thing. And then here, so just write it down here that it will give how much uh, OH minus ions, 3 OH minus ions. Just calculate this from with respect to this equation. It will give 3 OH minus ions. So it will basically it will be minus 3 OH minus, right? So minus Al3, AlOH whole 3 minus 3 OH minus will give you Al3 plus because it's taking OH 3 OH minus. Simple as that. Then the same thing here, it's taking 2 OH minus, so 1 OH minus will be the remaining one, so I'm getting LOH2 plus. Then in case of this one, only taking one, so there will be two remainings, LOH whole 2 plus. Then we are getting from LOH3 to LOH3. This is simple, no changes there. And in case of the reverse order, I am getting one LOH minus 4 minus LOH whole 4 minus 1. So these things we are getting. And this is also very easy, H1H plus plus 1 F minus, I am getting HF. So you will write the tableau. You know what are the components here. You know what are the species is. Write it down here. So I'm getting from 1, 1, this will minus 1, then 3. Actually, what is the concept behind this? I'm just telling you the concept. So it will be better for your understanding, right? So here you can see that this, suppose there is something called this one is present, right? ALF3 is present. So this ALF3 or Al3 plus can take up the hydrogen ion, it can take up, sorry, it can take up the fluoride ions, okay, and release this H plus ions. it can release the H plus ions, so it can contribute up to 3, right? It can take up 3 F minus ions. See, Al3 plus can take up to 3 F fluoride ions, right? So if Al3 plus is taking 3 fluoride ions, so it will produce 3 H plus ions, right, in the water. So it can contribute 3 H plus ions. Are you getting my point? Because otherwise this H plus and 3 H plus and 3 Fe minus will produce 3 HF, right? So in that way, we can say that if L3 plus is taking 3 Fe minus ions, then we can release 3 H plus. So that's why we are writing the same as 2, same as 1. Just think about that. From these equations also you can get it, right? From this, if you just write these equations, then also you can write this tableau. But for your better understanding, just think about the background concept. It's very important to know the background concept, how this is actually occurring. It's not just mathematical expression, right? So just write it down, and for a phi minus ions also, just check from these equations and also from this background concept, and you will get this tablet. Just write it down. You know how to write it down. H plus equals to H plus, then minus 1, and then 3. This is the 3. 3Al3 plus, then 2AlOH 2 plus, and so on. So I hope that you can also write for Al also similarly. So this was the concept behind all those things. We will go to the next question. This is a solution. This is a question about the solution is prepared by adding aluminum fluoride AlFe3, and the concentration is same 0.1 molar in the distilled water. Okay, and the predominant Al species is aluminum species at pH 3, 7, and 10 at equilibrium respectively are, you have to find out. And you can consider that no precipitation has occurred. So we'll go for the solution. So the correct answers will be A, AlF3, AlF3, and AlOH4 minus. We will check how to do it, right? So we'll use the fume index software here again. So the L concentration will be 0.1 molar and F minus the fluoride concentration will be 0.3 molar. Why? Because from 1 AlF3, I am getting 1 L and 3 F ions, right? From 1 mole of this, I am getting 3 moles of Al as aluminum ions, and 1 moles of aluminum ions and 3 moles of fluoride ions, right? Simple as that. So I'm multiplying with 3 in case of fluoride. So 0.3 molar. Just give the inputs, whatever data you have. Fix the pH. Fix the pH also. Don't only go for this Al3 plus and F minus. Also try to fix this pH 3. Then run the fume intake software, and you will find this table, the percentage distribution table. So from here also you can see AlF3 is the dominant one in case of pH, because this is the highest concentration we have, 67.8%, 67.8% compared to rest of them, right? So we'll go for the next one, the pH 7, same thing, nothing else, like no need to think anything else. So in just fix the pH, other things will be same, other data will be same. Just fix the pH from 3 to 7. Now it's 7. Run the fume index software, you will get this table. As simple as that. From here also I can see the 66.48%, so it is almost 49% in case of AlFe3. So in case of pH 7 also, the dominating species will be AlFe3. We'll go for the next one for pH 10, same procedure, and we are getting the highest concentration 81.6%, and these for AlOH. whole 4 minus, right? So this will be the predominant species. The next question, the solution is prepared by adding AlCl3 and the concentration is 0.01 molar due distilled water. Each can be adjusted by adding NaOH or HCl into the solution. The pH at which LOH3 starts to precipitate is you just have to keep some words. The nearest answer, like whatever the nearest one, you can go for. Okay, the correct answer will be 4.8. We will see how to solve this. So go to ViewIndex software, right? You have the data. What is the CLT concentration? 0.1 molar, 0.01 molar, and pH you can adjust, right? So give the inputs. L3 plus concentration will be 0.01 and Cl minus will be 0.03. Same as the previous one. In case of the previous question, it was AlF3. Now it is AlCl3. So you know how to do it by multiplying with 3, right? So that's it. You can check the table here whether it's correct or not. Then you go to option there. There is a solid phase exclude species as option, right? And then click this specify possible solid phases option. Then add Al, OH whole 3Am as solid, amorphous as solid. So that is our question, right? Al, OH whole 3 with this is our target species, right? When it will start precipitate. So that is the question. So you will find it. Just let me show you quickly. You will find it. Here you can find the specify possible solid phases. If you go there from here, just click here. Don't make it blank. Just click here. Then it will limit the list. You can check this one. Just add back to the main menu. That much you have to do here, right? So you will find this option from here, solid phases and excluded species. Go here, specify possible solid phases, and from here only you will get it. Then go to this multi-problem or sweep menu, and then select the sweep. One parameter is varied, right? And then go for all the details. Like whatever the details are given here, I'll show you quickly. Just watch, just try to see whatever is written here, and then you should run the vMintech software. So first go there, the multi-problem and sweep, then click this option, then go put the values here, just like that. Okay, I'll show you quickly. So if we go to this option, Just select this one, sweep one parameter is valid, then pH, this you can write this 67 numbers or the steps you will go. The start value is 1 and the increment will be 0.2, something like that. And from this list, you should add this. Suppose this is L3. What are the species, possible species? L3 plus. Go here, check this L3 plus, right? Then ALOH, if you just add, it will come like that. Then go here, then select this ALOH2 plus, right? What is it? Yeah, this one. So it will come here. So just like that, go for all the species, whatever mentioned here. You can check from this afterwards when you will get this PDF through the NPTEL's website. You can check the list or you can try to do it by yourself. I hope all of you know what will be the possible species, available species in our case, and then run this element, right? And if you just look the data there, after running the Vmintek, you will find that at from pH 4.8, ALOH3 is getting generated. So we can say from that point, uh, we will get this. So if you go this sweep results, you will find that from this almost this point, this is a 0 from here, 9.6, 9.7, this is getting increasing. So before that it was 0, ALOH whole 3. Then from this point, it is getting increased, right? So this pH is corresponding to the 4.8, right? This is a 4.8. From 4.8 it is getting increased. So nothing else. So we can say that from this pH, from pH 4.8, this ALOH whole 3 is getting precipitated. So that is the main concept behind this question. We'll go to the last question. This solution is prepared by adding LCl3. The concentration is same, 0.01 molar. This is the extension of the previous question. Nothing new. You can take the data, whatever you have calculated, and try to solve this. So then out of L3 plus ALOH 2 whole 2 plus, let's check the notation, and then ALOH2 plus ALOH3 aqueous form, then ALOH4 minus form, and ALOH3, all these species is right. So you have to find out which will be the dominant species at pH 3, 5, and 11 when equilibrium. So when the solution is at equilibrium, you have to find out like when at the equilibrium of pH 3, pH 5, and pH 11, what are the dominant species. So these are the options. Okay. This is very easy one because we already solved this. So you have to go up to this step, up to this step. You will get the table, right? From the table, try to convert it into Excel sheet. So you will get the table from here. So this will you will get this table. Print to Excel. Go here, the print to Excel. You will get the Excel sheet with respect to pH and all the concentrations of all the species, right? With respect to all the species which we are concerned about. So just go there and try to plot this graph on your Excel, correct? So on your Excel sheet, you can plot this graph. This is a log C. This is a log C. versus the pH concentration. pH, this is the pH variation from 0 to 14, and this is the log C. Y-axis is the log C axis. So if you do this, you will find these curves, right? From these curves, you can easily say that at the pH 3, which one is the dominating? Suppose this is the pH 3. Sorry, this will be the pH 3 approximately. So this is Al3 plus, right? So in case of pH 5, where is the 5? This is the 5. This will be AlOH 3 minus 3. Sorry. And in case of 11, it will be AlOH 4 minus. So from this graph only, we can say what are the dominant species at different pH, right? So, uh, okay. Now this was the previous from the previous week or the last week. So thank you everyone for joining today's session. We'll meet on the next Saturday.